Okay. Here we go. Finally. Oh, close back again. Okay. I think what it is, the computer, I hit a button and nothing happens. I hit it again and then it undoes itself. So I'll try to be a little more patient, but I don't know why things are so incredibly slow today. Now it's a black screen. Pretty exciting. Okay, you got a screen. I still don't. I've got the Windows symbol. And now we're in presenter view. I have to get out of that. And now I'll get back into something we both see. Okay. I think we may be there. All right. Now, first, ask it before again. Any questions? Anything we've done up till now? None? Okay. What we're doing is using factoring to solve equations. Again, remember that each time we pick up new factoring techniques, we also develop more power for solving equations. Let's consider how we can use difference of two squares, factoring pattern to help solve certain types of equations. Sum and difference of two perfect cubes, you can use that sum, but they're just not as common as the difference of two perfect squares. So we're going to focus on those. So help me do this one. How do we solve that equation? Anyone got an idea? There are a couple ways to do it, so let me know what you're thinking. Second? I like that idea. Okay, and by the way, I've got to get my pen activated here. Okay, so we subtract 16 from both sides of the equation. That gives us x squared minus 16 equal to, whoops, 0. Okay, that's what I meant to mark out. Now, where do we go from there? Any ideas? Ah, excellent. Okay, how do you factor? X minus 4 times x plus 4, difference of two perfect squares, equals 0. Now what? So each of them equals 0. We have a product of two entities equals 0. One of them's got to be a 0. So either x minus 4 is equal to 0 or x plus 4 is equal to 0. So what do we do with the first one? Okay, the second one, okay, yeah, the first one we add 4 to both sides, and that wipes out the 4 here, and that gives us x equal 4. Over here we'll subtract 4 from both sides, and that gives us x equal minus 4. Now, I was just a little surprised that some person, well, it didn't work, did it? Didn't give me another suggestion on how to work this problem. Does anyone want to make a suggestion? What was really the first thing that came to your brain? Goodness gracious, this is not working. What would be another way to solve that? Say again?
I just say go straight back. I don't know if it's possible to do it.
Okay, and what do you mean by that?
You see the x squared or whatever, I know I got to add 2 x's, so I put x in one bracket and x in another bracket.
Okay.
Then I got to give 0 going to 16, so it'll be 4 times 4.
Okay. All right. I like the way you're thinking. Another way of saying that is taking a square root of both sides, basically, right? And that is one way to proceed, and it does the same thing you did. If I took the square root of both sides, what would my answer be? Help me. X equal 4. Okay, did someone say something else? I thought I heard someone say something. Okay? Thought it was the right answer. This is half the answer. You get partial credit on that. Why? What's that? Okay, we don't have the negative. Anytime you take a square root of both sides of an equation, you have to do a plus or minus. Have to do a plus or minus, okay? And in this case, you do, if you had written down plus or minus 4, that would have been the right answer, okay? So you could do it that way, but because it's so tempting just to look at that and say x equals 4, forgetting about the minus 4. If you do it this way, it smacks you in the face and you can hardly miss it. So this is the preferred way to go. Good choice. Any questions on that? Okay. Let me clear that and see how they did it. Okay, they wrote it again. Good idea. Then they subtracted 16 from both sides. They factored the left-hand side, x plus 4 times x minus 4. The order doesn't matter. Then they set, because of zero product principle, product of two entities equals 0. One of those two entries got to be 0. Either x plus 4 is equals 0, or x minus 4 equals 0. When you solve each of those, you get x equals negative 4, x equals positive 4. And they always like to put it in solution step. Okay? I really don't care. If I see this and that, I know it's right. If I see x equals plus or minus 4, I know that's right. But if you're checking your answers in the back of the book, expect to see something like this. Know what it means and that you've got the right answer, right? All right, any questions on that? That was example 6, okay? Now, in example 6, we use the property, as we've said over and over again, if a product of two entities, they don't have to be numbers, they don't have to be letters, they could be any two entities, is equal to 0, that's true if and only if one or the other of those has to be 0. You can't give me two entities multiplied together equals 0 and one of them not be 0. You can't do it. This property can be extended to any number of factors whose product is 0. For example, if you had A times B times C, remembering A can be some entity, B is another entity, C another entity, then if the product is 0, then one of those, at least one, has to be 0. Either is A 0, B is equal 0, or C is equal 0, or multiple ones. At least one of them has to be 0. Does that make sense? Okay. Now, they're skipping example 7, 8, 9, and 10. Okay. Want to do those? Okay, let's do them. This doesn't have an option of a clean sheet of paper, okay? So what I think I'll do is go back to this slide and we'll do the others on this slide. Example 7. Solve this. 9x squared is equal to 64. Can you do that? How? Subtract 64 from both sides. Good choice. If I could write. What does that give you on the left? 9x squared minus 64 equal to 0. Excellent. Now what? Okay. Always look first for common factors. You don't have any, so you can go on to your difference of two perfect squares. That would be 3x plus 8 times 3x minus 8. Very good. That's equal to 0. Okay? Now what? Either 3x plus 8 is equal to 0, or 3x minus 8 is equal to 0. One or the other has got to be true. Next, let's take that first one. Now it's a linear equation. You got x by itself, you got an x, just a plain x, so now we isolate it. And how do we do that? Subtract 8 from both sides, and that gives us 3x equal negative 8. And then what? Divide both sides by 3, and that gives us x is equal to negative 8 thirds. Oh, no, your answers can't be fractions, can they?
Yes.
Of course they can. We love our fractions, and we're kind to them, okay? Okay, that's one answer. How about the other? Add 8 to both sides, and that gives you 3x equal to 8, and then divide by 3, and that gives you x equal to positive 8/3. Very good. Let's see how the book did. Oh, they got it right. Good for them. Okay. All right, any questions? Okay. No questions? All right. I'll leave it up there a little bit longer if you need it. Okay, everybody got it? Still writing? You okay? All right. Let's erase all that and go to example 8. Solve this one. 7x squared minus 7 is equal to 0. Can you do that? How? Say again? Factor what out? 7. Okay. Look for greatest common factors. In this problem, it's 7. Okay. So let's factor that out. 7 times, and what do you have left? X squared minus 1. That's equal to 0. Are you through factoring? No. There's still, again, don't forget your 7. We will forget it in a little while, but not now. X plus 1 times x minus 1. And that's equal to 0. Now we've got a product of 3 entities equal to 0. That means at least one of those has to be equal to 0. Now there's a couple ways you can do this. In fact, we could have done it in the previous step. I was listening to what y'all said. What we could have done up here is divide both sides of the equation by 7. That's legal, isn't it? What can you not divide by? 0. Okay. But you can divide by anything else as long as you do it both sides. That would have gotten rid of your 7, okay? Or, but when you got it down here, this says that either 7 is equal to 0, or x plus 1 is equal to 0, or x minus 1 is equal to 0, right? Is 7 ever equal to 0? Not in this universe, okay? So forget that. That's not a potential solution. That's why you could have divided it away. So our only reasonable answers are x plus 1 equal to 0, or x minus 1 equals 0. Okay, and then what do we do with that? Subtract 1 from both sides, and that gives us x equal negative 1, or add 1 to both sides, and that's equal x equal to plus 1. Good deal. Oh, and I've been forgetting to do this, and we really should. I like to always check my answers because I hate making mistakes, okay? So I make a lot of them. So when you take a negative 1 and square it, what do you get? Positive 1 times 7 is 7 minus 7 is 0. That works. Same thing here. 1 squared is 1. Yeah, that's same deal. Okay? Should check all your answers, but that's not required unless you don't mind making errors. Okay. So, not that y'all would make any errors. Okay. Now. Okay. Let's go on to example 9. X to the 4th minus 16 is equal to 0. Hey, they've already got it set up equal to 0 for us. What would you do with that? What would you do with that? What's your F word? All right, that's, okay, we're doing this one. Say again? Add 16 to both sides, and then take the square root. You can do it that way. What is this section all about? Factoring. Well, let's factor it. Okay, you could do it the other way. Well, let's factor it. Is that factorable? Okay. Huh? X squared minus 4 times x squared plus 4. That's equal to 0. Are you through factoring? Why not? Yeah, well, you still got one that will factor. Which one of those will factor? Oh, they both will? Oh, the first one will. Okay, what does that give you? X minus 2 times x plus 2. How about that second one? Will that factor? Absolutely not. So don't even try. Okay? X squared plus 4 equals 0. Okay? Now, what do we do? Okay, either x minus 2 equals 0, or x plus 2 is equal to 0, or x squared plus 4 is equal to 0. Okay, let's solve each one of those if we can. First one, add 2 to both sides, and that gives us x equal 2, or subtract 2 from both sides, and that gives us x equal negative 2, or what do we do with that one? Second? We can't factor it, no. So you want to try anything else? You want to subtract 4 from both sides? Let's try that, might not be able to do it. Okay, and what would that give us? X squared is equal to negative 4. Now what? Okay, so, okay, I heard an x equal negative 4 and x equal 4. Is that what I heard? Or do you mean 2? All right, okay. Y'all are leading me astray here. Okay, I got to watch you. Okay. X equal negative 2 or 2. Let's see if those work. Okay. If I put negative 2 in here and square it, what do I get? Negative 2 squared is? Positive 4. That don't work, so scratch that. Okay. How about if I put a positive 2 in there? No, that doesn't work either. So that doesn't. Who gave me those answers, huh? All right, those don't work at all. Can you give me anything that when you square it, you get a negative 4? We just tried those and they didn't work, didn't they? Guess what? When you square any real number, positive or negative, you get a positive number. How in the world are you going to get a negative number? Not in the real number system. Now, I was sort of hoping someone would tell me this at this step when I said x squared plus 4 is equal to 0. X squared is always what? We just said it. Positive. You add 4 to a positive number, are you ever going to get 0? Never. Okay? So it's not going to happen. Okay? This has no solution. So we only have 2 solutions. Even though we have a degree 4, all that tells you could have up to 4 possible solutions is 4 or less. We only have 2. And they do work. You can go back and plug them in. 2 to the 4th power. You want to know what it is? 2 times 2 is? 4 times 2 is? Times 2 is? 16 minus 16 is? 0. That works. And negative 2, same thing. Negative 2 times negative 2 is? Positive 4 times negative 2 is? Negative 8 times negative 2 is? Positive 16 minus 16 is 0. Yeah. Both of those work. The others do not. There is no solution for that last That was a little on the tricky side, but doable, okay?
You know, you said that was the last one don't have no solution.
Right.
But couldn't we just look at that and tell it wasn't gonna work? Because you always say it whenever you have a problem.
Okay, yeah, because it would not factor. That's the first good sign it doesn't have. It doesn't mean it won't have a solution, but it's a sign that it might not. We'll later get to, see, all we're dealing with here are integers. A little bit earlier we had a fraction. Those are rational numbers, okay? There's another set of numbers stuck in there, we'll get to that in a later chapter, called irrational numbers. Has nothing to do with gender, by the way. No, I didn't say that, okay? So, they're just irrational numbers. And that could, if this were x squared minus 5 equals 0, that does have two solutions. Plus the square root of 5 and minus the square root of 5. So those are irrational numbers, okay? We haven't done those yet. Don't worry about them. I hope you won't run into them until we get to that chapter, okay? So you can't guarantee just because you can't factor it's not going to have a solution, but it won't have any rational solutions, okay? All right, good deal. That was 9, I believe. Let's go to 10. All right, number 10. Solve this. X cubed minus 49x is equal to 0. Hey, they already got it equal 0 for us. That's a good sign. What would you do first? Any ideas? Ah, okay, so we can do what? Factor out an x, okay? And what does that leave us with? X squared minus 49 equals 0. Now what? Are you through factoring? Why not? Okay, so your x is still there, and this will give you x plus 7 times x minus 7. Excellent. Equals 0. Now we got them all in linear things. What do we do from here? Okay, and what does that give us? Either x equals 0, or x plus 7 equals 0, or x minus 7 equals 0. X equals 0, there's a solution right there. How about the next one? Subtract 7 from both sides, and that gives you x equals negative 7, or add 7 to both sides, and that gives you x equals 7. And by the way, once you have done a few dozen, hundreds, or these, or whatever, and you start saying, hey, I know what that answer is, you can write it down. You don't have to write down every step. I'm writing them down just to help plant that concept in your mind. Once you got it, if you want to skip some steps, you certainly can. 3 possible solutions. You reckon all 3 of these might work? Let's try 0. 0 cubed is? Minus 49 times 0 is? 0. 0 minus 0 is 0. Yeah, that works. Oh, man, why did I want to do this one? Negative 7 cubed. I'll let y'all do this on your own, right? Pull out your calculator and plug it in and see. But, actually, it's easier than that. Negative 7 cubed is negative 7 times negative 7 times negative 7, right? Okay. Well, what's negative 7 times negative 7? Positive 49. So you have a 49 times 7 minus 49 times a negative 7. Wait, it's a 49 times negative 7. Okay, I didn't remember saying. So do it this way. 49 times negative 7 minus 49 times negative 7. And what does that give you? Same thing, but opposite signs. This one's negative, that one's positive, but they're the same numbers. I don't care what number they are. You can figure them out. That's 63. 343, I think it is. Is that right? Yeah, 343. But minus 343, positive 343, that equals 0. Okay. And you can do the same thing with a positive 7. That will just give you Positive 343 minus 343 equals 0. It's the same. Okay, good deal. That was example 10. Any questions on solving word problems? Say again, yes. All three. If you wrote it in set notation, it would be squiggly things. They're called braces, -7, 0, 7. But the order doesn't matter. But yeah, you have three solutions. I would do this to keep from having to write the others just because I'm plain lazy. Okay. Good question, though. Any others? All right. By the way, on your test, I'll have a blank that said, put your answer in the blank, and then I know where it is. Quizzes, too. All right. Whoa. Well, let's just scroll through this. This is that problem, example 6 we did a while back, so don't worry about this. Here we go. Now we're going to solve word problems that involve factoring. Okay? We love them, don't we? Yes. The combined area of two squares is 40 square centimeters. Each side of one square is 3 times as long as a side of the other square. Find the dimensions of each of the squares. What would you do first? Say again? Draw some squares, is that what you said? All right, I love it. Draw a picture. Okay, how would you, I'll draw one square, okay? My best rendition is pretty lousy. Okay, that's close to being a square. Now, how does the other square look? Certainly it has right angles and everything, but what does the problem tell you? The next one's got to be 3 times as long. So that would be each side I don't draw very good squares. I don't draw very good anythings. My mother would be embarrassed. She was a very good artist. I am not. Okay. So, combined area of two squares is 40 square centimeters. We'll get that in a minute. Each side of one square is 3 times as long as the side of the other square. Find the dimensions of each square, each of the squares. Now, I like to cheat a little bit. I like to find what they're looking for, the dimensions of each of the squares. Okay? Well, the dimension of this square would be how long that is or that is. They're supposed to be all the same. And the dimension of this would be each of those. Obviously, not quite square, but just imagine they are. Which one of those do we know the least about? The little one or the big one? The little one. So let that be your variable. Let, and what do you want to name it? You get to choose your variable. Say again? X, okay. Let X equal the length or the dimension of the small square. Okay, so I want to label them. That's X, that's X, that's X, and that's X. Then, what would be the dimension of the larger square? 3. And 3 times X is 3X. Okay. Okay. Dimension of the large square. Okay. So this will be 3X. That'll be 3X. That'll be 3X. And that'll be 3X. You see how I was drawing them. I almost tried to get each one of those. Okay. Now we go back to the first. That handles this thing. Each side of one square is, that'd be X, is 3 times as long as each side of one square is 3X, is 3 times as long as the other. That's what that middle sentence tells you. Y'all saw it right off the top. The last sentence gave us our variables, or we made it up. Now we need to do the area. What's the area of that first square? We'll call it A1. What's that? What's the area of a square? Length times width. And what is your length on this one? X. And what's your width? X. So that would be X times X, which is X squared. Very good. Okay. Now, what's the area of this one? Okay. He can't read back there, can he? Okay. Isn't that 3x? Oh, you did. I thought you said 2x. I'm sorry. I can't hear. Okay, sorry about that. Okay, so that'd be 3x. Sorry about that. Times 3x. All right, and what does that give you? 9x squared. You got it. And then what it says, combine areas. How do you think we're combining those? Adding them together. And when we add them together, that would be a is equal to, well, let's just not even write the a down there. That may be confusing, so I won't write it. I did, but I'm going to erase it. Okay. Okay. What's the combined area of those two? Say that a little louder. Okay, wait. I thought you said add them, so let's add them. Let's do A1 plus A2. Is that what you said? Okay. All right. So what is A1? X squared plus 9x squared is equal, read the sentence. 40 square centimeters. Okay. I'm going to leave off the units for now, but we'll go on. What do we do next? Second? How about let's just adding them together, okay? Yeah. What would that be? 10x squared is equal to 40. Now, what do you want to do next? Say again? Divide both sides by 10. I like it. He's nice and lazy. I mean, okay, never mind. Okay, divide both sides by 10. Okay? And 10 will go into 40 how many times? 4 times. So now we have x squared is equal to 4. Now what? Subtract 4 from both sides. You could have done the 40, but lazy people do it other ways. Okay. Subtract 4 from both sides. What does that give you? X squared minus 4 is equal to 0. And now what do we do? Either x plus 2 times x minus 2, that's equal to 0. And what does that give us? Okay, x plus 2 equals 0, or x minus 2 equals 0. Subtract 2 from both sides, and that gives you x equal negative 2. That would be centimeters, or add 2 to both sides, and that would give you x equal positive 2 centimeters. Okay, I want someone to come up to the board and draw me a square whose length is negative 2 centimeters. Anybody? Okay, you get extra points if you can draw me a square whose length is negative 2 centimeters. You can't do it. Okay, that's why I could give off extra points. Okay, now, so this is, even though mathematically this is a perfectly correct answer, physically that makes no sense whatsoever. Okay, so our only answer is x equals 2 centimeters. Let's see if that's right. If this x is 2 centimeters, what's the area of that? 4 square centimeters, okay? If this x is 2 centimeters, what's that length? 6. And what's the area? Area. 6 times 6. You're listening to him. He adds, you know. Okay, right. All right. 6 times 6 is? 36. And you got 4 plus 36 is? 40 square centimeters. Sure enough, that works. Right? Good deal. See, these word problems are fun, aren't they? No. Yes. Okay. Well, we sure hope so. Oh, yes. Hey, guess what? You know, in real life, okay, if you were working for your boss, okay, I don't think the boss is going to come in and say, can you do x squared is equal to 4? Can you solve that for me? I mean, most bosses even can do that, you know. Well, they're going to come in is, hey, we got a problem here. Here's what the problem is. Can you find the solution to it? Guess what that's going to be? A word problem, okay? You've got a problem. That's what math is all about, solving problems. So, man, I would cheat you if I didn't have some word problems on there. I wouldn't be preparing you. Oh, you wouldn't be too? Yeah. My goodness. Who wants to lend her money? No, never mind. Okay. All right. All right. Let's see how they did it. Let's erase some of this stuff. In fact, all my stuff. And let's see what they do. They wanted S to represent the length of the smaller square. Why? Because that's the one we knew the least about. Because the bigger one we knew its side was 3 times as long as the smaller. Okay? So S would be the length of the smaller square. 3S represents the length of the larger square. Then the area of the small square is S squared. The area of the larger square is 3S quantity squared. That sum is equal to 40 square centimeters. They skip a lot of steps here. I think that would be useful to explain a little better. Well, that would be S squared plus 9S squared is equal to 40. Sure enough, that adds to be 10S squared is equal to 40. And they did just like our lazy person did, dividing by 10, and that gave you S squared is equal to 4. You could subtract 40 from both sides and then divide by 10. But, why not divide early so you don't have to write as much, okay? Then subtract 4 from both sides. That's S squared minus 4 is equal to 0. And that would be S plus 2 times S minus 2 equals 0. That would give you either S plus 2 equals 0, S minus 2 equals 0, S equal minus 2, or S equal plus 2. Now they get, because S represents the length of the side of a square, the solution -2 makes no sense. You can't have squares with negative length, okay? So you disregard it, just pretend it's not there. Your answer is S equal 2 centimeters, okay? Well, then the large square would have a side of 6 centimeters. 3 times 2 is 6. 2 squared is 4 plus 6 squared, 36. That's 40. Sure enough, that works. And they ended the problem right there. All right. Now, point something out to you. I hope I did this before. At the end of the section, they have a little thing called a concept quiz. Okay? These are true-false questions. Don't expect to see these on quizzes, okay, or tests. But they are worth looking at to see if you can figure out if they are true or false and why they're false, and stuff. And then flip the page over and you'll see answer to the concept quiz. You can quiz yourself and see if you get them right or not, okay? If you don't get them right, figure out why you missed them. If you got them right, good deal. All right, so you can do those on your own. Homework exercises, though, do any of the odds, because the odds have answers in the back. Any of the odds 1 through 25. Any of the odds 27 through 49. Any of the odds 51 through 67. Any of the odds 69 through 82. And any of the odds 83 through 91. Okay, now especially those word problems. We only did one type of word problem. Those were squares. That would be sort of like number 85 and some of those. There are some of these word problems that just give problems about numbers. I would definitely work 83 too, because that's a fairly simple one. And then some of the others, and a lot of those others are like the one we did. Okay, there are some that are maybe a little more involved. All right, any questions? Then let's get out of 3.5 and move on to 3.6. Okay, and we've got plenty of time. Okay, so let's end that. Oh man, let me see. I don't know where it went. It should not be starting over again, but it's buried in there somewhere, but I'll go on and start over. Have to go through all these things. It should have gone right back to the previous thing, and I shouldn't have to do all this again. Resources by chapter, chapter 3, lectures 3.6. Okay. Now, I was about to say when we finish 3.6, actually I'll go a little bit into 3.7, and I'll give you your quiz then. In fact, when we finish 3.6, but I'll go on and do some 3.7 as well. All right, let's set up the slideshow from the current slide. The computer is picking up speed now. I think it's a little... when we finish 3-6, I'll give you a take-home quiz. Huh? Yeah, the quizzes you take home, the tests you do in class.
On the test is about what you said, about 10 questions.
The quizzes are about 10. The tests are about 20.
And out of those 20, about how many word problems?
Oh, dozens and dozens, I'm sure. You know, no, I'm just kidding. Just a few. Just a few. Yeah. Yeah. Okay.
So when you say G, you mean like 2, right?
Yeah, about 2.
You probably more than 2, ain't you?
You know, when I say, have you got any questions on math, I don't get this many questions. You know, when it comes to word problems, I get questions, okay? Hey, we love our word problems. Whoa, what am I doing? Wrong key. Okay. Oh, man. Oh, wow. Okay, we're still in polynomials. Many terms is what that means. Now we're going to continue factoring. I thought we were through, didn't you? But now we're going to be factoring trinomials. What do we mean by trinomials? 3 terms. Notice all the ones we factored so far, not all of them, but a lot of them, factoring out common monomial factors. That was just one term you're pulling out. And then some are difference of two perfect squares, some are difference of two perfect cubes. Those are all binomials. So how are we going to do trinomials, factoring trinomials? What we'll do is factor trinomials of the form x squared plus bx plus c. Those are the easiest because you don't have a coefficient for the x. Once we get those down, then we'll do ones that we do have a coefficient for the x squared, ax squared plus bx plus c. And then we'll look at some special ones, perfect square trinomials, and then we'll do a summary of all your factoring techniques, the ones we did last section and this section. Okay? So, one of the most common types of factoring used in algebra is the expression of a trinomial as a product of 2 binomials. Does that make any sense to you, or is that just blah, blah, blah? Okay, let's do a product of 2 binomials. Binomials would mean 2 terms, okay? So, let me get my pen back. I could have done it the other way. This is okay to do it that way. Okay. Give me a variable, any old variable. X, okay. I'm surprised, okay. Give me a plus or a minus sign, I don't care which. Minus, okay. Give me either a letter or a number other than X. 10, okay, that'll be fine. 2, okay, 2. All right, goodness gracious, ooh. All right, now I'm going to use the same X. You want a plus or minus here? I don't care. Plus, okay. Give me another number, not 2. 4, that sounds good. Okay. Now, how do we multiply these two? These are binomials, right? 2 terms. Okay, how do we multiply those 2 binomials? Product means multiply, right? So, form, exactly. And what does FOIL stand for? First is? Okay, first is x squared. Then outer, you're absolutely right, that would be plus 4x. Then your innards, negative 2x, negative 8. Okay, your last, okay? And then what do we do? Combine like terms, that gives you x squared plus 2x, I can't write, minus 8. And guess what we have? How many terms? 3, that's a trinomial. That's what that says. Most common type of factoring in algebra is the expression of a trinomial as a product of 2 binomials. So we're going to do our multiplication backwards. Remember, factoring is like division. So guess what I'm going to do? Books don't call it this. I call it unfoiling. Okay? That's how I'm going to approach it. To develop the factoring technique, we first look at some multiplication ideas. They're doing the same thing we just did. They're doing x plus a. They're not using numbers. Times x plus b. Use the distributive property, which I don't think of it. I do foiling. But it's the same deal. And it's x plus a times x plus b. I mean, x times x plus a plus 8 times x times x plus b plus a times x plus b. And when you multiply those out, you get your foiled, thing. x squared plus bx plus ax plus ab. But then you combine these two terms because they have x. That's exactly what we did. We did it with numbers. I think it's easier with numbers than having letters. Note that the coefficient in the middle term is the sum of a and b, the last term in the product. Okay? See, this is a product of a times b. This is the sum of a and b. We're going to use that to our advantage. These two relationships can be used to factor trinomials. Let's consider some examples. Okay. Here's one. Okay? Now, I suggest, this is my way, and you can do it any way you want to as long as it works. Okay? Here's how I do it. I say, let's assume that this is going to be a factor of two binomials. So I'm going to put binomials in there. So if I'm unfoiling, I start with the first. What's the only possible factorization of x squared? X times x. Okay? Write those down. Okay? See, this isn't bad. Now, but when I'm unfoiling, I don't know how to spell too well. So I jump to the last term, except I don't even care for the whole term. I'll look at the sign of the last term. What is it? Positive. What does that tell you about these two signs? They've both got to be the same. They both don't have to be positive. How do you tell if they're positive? Look at the middle term. If it's positive, then they're both positive. Okay, that's if the last term is positive. We'll later do one that's negative, and that's a different, slightly different rule. Now, what they just pointed out before, we're looking for two numbers that multiply to be 12, but add to be 8. Say again? 6 and 2, you just factored a trinomial, didn't you? 6 and 2 or 2 and 6, it doesn't matter which. I always like to check it to make sure I got it right. X times x is x squared plus 6x plus 2x is 8x plus 12. Got it. Okay. See how easy this is? I wish I could make it harder, but I haven't figured out a way to do that. Okay. So, say again? Okay. Okay. Look, we're running. Wait, I erased the wrong thing. I want to erase all ink on the slide. Okay. And go back to my pen, I think. Okay. Let's see how the book did it. Okay. Okay, they do it maybe a little more complicated. I don't know. If you like this way, do it their way. We need to complete the following two integers whose sum is 8 and product 12. That's exactly what we got. They didn't tell you what to do with the signs. I told you that, because we're going to run into that later. Okay? They just jumped to this part, and sure enough, that's 6 and 2. They write them all out. Okay? If you need to, do it. Don't knock it. And you look for the ones that work. Later, we will be writing them all out when you get to more difficult problems. Okay? Because 6 and 2 is 8, and 6 times 2 is 12. We then write this as x plus 6 times x plus 2, and sure enough, you check, multiply, FOIL it, it works. All right. Now, they skipped number 2. So let's go back and do number 2. Okay, let's do it here. Example 2. Factor this. X squared minus 10x plus 24. Okay? Now what we do, we're always optimistic that we can factor that baby. Okay? And where do we start? First term. It's the only possible factorization for x squared. X times x. Okay? Then where do we look next? Sign of the last term. What is it? Positive. That tells you that these two signs have to be? Say again? The same. What are they going to be? Plus or minus? Look at the middle term. Minus. Okay, so they both got to be minuses. Both got to be the same because it's a plus at the end. The middle term's minus, so that means they both have to be minus. Now we're looking for two numbers that multiply to be 24, add to be 10. 6 and 4. Perfect. Very good. And we check it. You don't have to, but I like to. X squared minus 4x minus 6x is minus 10x plus 24. Yay. Got it. Okay, they set up tables, they do all this kind of stuff. If you like doing that, do it, okay? Knock yourself out, okay? Let's do the next one. I think we have room. X squared plus 7x minus 30. Ooh, he threw in a minus sign on us, okay? How are we going to do it? We're going to be very hopeful that we can factor that. Where do we begin? X times x, very good. Then where do we look? Sign of the last term. What is it? Minus. What does that tell you about these two signs? They got to be different. So one's going to be a plus and one's going to be a minus. Now what we have to do is find two numbers that when you multiply them, going to give you a 30. But when you add and subtract, they're going to give you a plus 7. Okay. Now, first thing that tells you, which is the bigger of those two numbers? The positive or the negative? Yes, because you wind up positive. Okay, so you want two numbers, multiply to be 30, but basically the difference is going to be 7. What is it? 10 and 3. And which is going to be with the plus, 10 with the plus, 3 with the minus. Look at that. Let's see if it works. X times x, x squared, minus 3x plus 10x, that would be plus 7x and minus 30. Got it. Okay? All right. Y'all like that so much you're packing your books, huh? All right. That gave us example 3. We will start next time on example 4. Okay? Top of the page, 160. Let me erase this mark here. Okay. Let me give you a few homework exercises in this section. Okay? There won't be many, but just a few. Ooh, this is a long section. Okay? I think you can start doing any of the odds 1 through 29. Okay? Well, let's see. Let's back off and make it only 1 through 23. Any of the odds 1 through 23. 165, right? Okay? All right, good deal. Any questions? Okay? Have a good weekend. You know what's going to make it a good weekend? Working those math problems. All right, good deal. Can it get any better than that? Okay, good deal. Pardon me?
You get me on the road.
Yes, I did. That's why I asked you to meet
You know my name?
Yeah, I found you. It was down there.
Yeah. All right, thank you.
All right, surely. I saw y'all scrimmaging, last Friday?
Yes, sir.
How'd that go? It looked pretty good.
Not at our place.
Huh? Yeah.
When we was playing, they won it the past 3 years.
Wait a minute. I thought y'all were scrimmaging the inter squad.
Oh, yeah.
Oh, you
About
did.
the Friday before that.
Oh, no. You did? How'd that go?
We lost.
You did.
It was a close game.
Close game.
Yeah.
Okay, you'll suck it to in the regular season, though, right?
Okay.
All right, good. Yeah.
I've been doing this in 1998.
Yeah, I knew you had, so hopefully it's review, right?
Yes, sir.
Does it make sense?
Yes, sir, it does. See, Math 98, I didn't know. I always got the sign wrong with Math 98 because, when you look at the last sign,
Yeah.
they're both the same. Then you look at the first sign and tell
Yeah.
you look at the last sign and tell they're both the same. You look
Yeah.
at the second sign and tell one plus and minus,
Yeah.
both plus. I always got the sign wrong because I never learned how to look at the sign.
Okay, does this make it any easier?
It is.
Super. Okay, I did something right today. Whoa! Red letter day. Okay.
We will be gone next week.
Oh.
Thankfully, I have Matt to help me with it. But
Okay.
what will we be going over?
We'll continue 3.6 and probably get into 3.7 for sure. And I'll probably give the quiz, but just when you get back, I'll give you the quiz. Okay.
So, I probably just do what we normally do and kind of work on those
Yeah.
problems.
And it'll all be recorded.
Yeah.
Yeah.
Okay. Well, thank you.
All right, glad
Also,
to.
do you want us to write down what we're gonna do for that essay? Or
Yeah,
just
anytime
turn
you
it
want
in?
to turn it in, yeah.
Or just turn the essay in? Because I've done my essay.
Oh, you have? Well,
Yeah.
then you can
I
turn
just
it
say
in
wrong.
if you want
So
to.
you don't need the paper.
No,
Okay,
if you,
well, I bring
yeah,
it
you'll
in.
be the first
Okay.
one. You got the first topic. It's
Okay.
yours. Okay.
Okay, thank you.
Yeah.
You mark them with tardy or just present or absent?
I just do present or absent. I don't mess with
Or
it.
that's trying not to be too late. I got we work out.
I know you do. I've had baseball players before. So.
As soon as I can.
Yeah. No, I know you're just lazy and a slouch. Yeah, I know. I understand. All right. Take care. Have a good weekend. I recorded all that, by the way.